metal carbonyls. The binary compounds of metal with carbon monoxide groups are called metal carbonyls. For example, NiCO4 is known as nickel tetracarbonyl. Classification of metal carbonyls. Metal carbonyls may be monomeric, means containing only one metal atom, bridged, in which two metal atoms are linked via some carbon monoxide groups, and polynuclear, which contain more than two metal atoms in a molecule. FeCO5, CO2CO8 and Fe3CO12 are examples of these three classes respectively. However, our course is limited to monomeric carbonyls only, hence we shall concentrate on them only. Examples of monomeric carbonyls. We are having 4 examples here. The first one is VCO6, that is vanadium hexacarbonyl. It forms black colored crystals and it is paramagnetic in nature. The second example is CrCO6, that is known as chromium hexacarbonyl. It's a colorless solid and its nature is dimagnetic. Third one is FeCO5, known as iron pentacarbonyl. It's a yellow colored liquid and dimagnetic. Finally, NiCO4, that is nickel tetracarbonyl. It too is a colorless liquid but dimagnetic in nature. The other examples are RuCO5, OSCO9, MoCO6, WCO6, etc. Generally, transition metals of 6th B, 7th B and 8th group or metals in 6th to 10th vertical column form carbonyls. Thus, all the metals are not capable of forming carbonyls. All these carbonyls are dimagnetic substances except VCO6, which is paramagnetic with one unpaired electron in its molecule. In metal carbonyls, the oxidation state of metal is 0. However, some carbonyl anions are formed. For example, VCO6 with one negative charge, in which the oxidation state of metal is negative, that is -1. Let us see the IUPAC nomenclature for metal carbonyls. Metal carbonyls are considered as metal complexes in which carbon monoxide groups behave as strong ligands. The ligand name of carbon monoxide is carbonyl. Hence, for example, NiCO4 will be known as tetracarbonyl nickel 0. FeCO5 will be called pentacarbonyl iron 0. And for anions, say MnCO6 with one negative charge, the name will be hexacarbonyl manganese -1 ion. Structures of monomeric carbonyls. In this category, we will first study NiCO4. This is a tetrahedral dimagnetic molecule, hence nickel must be in sp3 hybridized state. That can be shown as given below. nickel with atomic number 28, has the outer configuration 3d8 4s2. Now, in order to form the carbonyl, the 4s electron pair goes into 3d subshell. So nickel in the zero oxidation state and in pre-hybridization state has the configuration 3d10 with 4s and 4p subshell totally vacant. So that 4s and 3 of the 4p orbitals, they undergo hybridization as shown here, sp3 hybridization. Thus each sp3 hybrid vacant orbital of nickel atom will overlap with a filled sp hybrid orbital of carbon monoxide.